You will need the following tools to take airflow measurements: 10 mm drills, magnetic gauges, a pitot tube, some flexible hose to connect to the gauges, airflow stickers for duct labeling purposes, and a marker. All these tools and many more are included in Osprey's Air System Diagnostic Kit. The kit contains everything you need to take airflow readings. Please contact us for more information. To take a static pressure measurement, you need a pressure gauge. This one measures low to moderate static pressures, for example the vacuum at the inlet of a filter, and this one measures rather high static pressures, for example at the inlet of a process fan. On each pressure gauge you have two ports. One negative port at the bottom to measure negative pressure or vacuum, and one positive port at the top to measure positive pressure or overpressure. Connect the flexible hose to the negative port if you want to measure a negative pressure, like a vacuum, or connect the hose to the positive port if you're measuring a positive pressure or an overpressure situation. Before the measurement, try to feel if the duct is under positive or negative pressure. In this case, we're measuring a positive pressure, so the hose has to be connected to the positive port on the tool. Then proceed with the measurement. During the measurement, make sure to hold your tool vertically and that you don't pinch the hose. To measure the airspeed in a duct, you need gauges that have a double scale. Here you can see the pressure scale at the top and the airspeed scale on the bottom. There are different gauges for different speeds, low, moderate or high speeds. To measure the airspeed, you will also need a pitot tube, which will later be connected to the measurement tool. There is a hole at the tip of the pitot tube. This is where the total pressure inside a duct is measured. Then there are several holes all around the pitot tube that measure the static pressure. The total pressure is measured at the top outlet, and the static pressure is measured at the bottom outlet. The gauge that we are using will directly display the airspeed in meter per second or feet per minute. To connect the gauge to the pitot tube, you need to connect the positive port of the gauge with the top outlet of the pitot tube. Then connect the negative port of the gauge with the bottom outlet of the pitot tube. Before measuring the airspeed in a duct, it is very important to know the airflow direction. Once your pitot tube is connected to your tool, make sure the pitot tube is not blocked by blowing in it. Here you can see that the needle on the tool reacts when we blow in the tube, so we can proceed with the measurement. Insert the pitot tube in the duct and point it against the airflow. Measure the airspeed across the whole duct diameter and read off the airspeed on the tool. It is very important not to pinch the hoses and to always hold the tool vertically. Once you're done with your measurements, make sure to properly close the measurement holes with a sticker, magnet or duct tape. After you take any kind of airflow measurements, make sure to label your ducts. Typically, you have one round sticker that covers the measurement hole, one sticker that indicates the airflow direction, and one bigger sticker that summarizes the process parameters. We have the duct diameter, the static pressure which we just measured, the airspeed which we measured as well, and the airflow that can be calculated. Additional information about the measurement point, the process application and the date are also very important to document. To calculate the airflow or air volume in a duct, we use the following formula. The airflow equals the air velocity, which we measured, multiplied by the cross-section of the duct. The cross-section of the duct is calculated with the duct diameter. For metric units, The airflow is expressed in cubic meter per hour, the velocity in meter per second, and the duct diameter in millimeter. To get all the units converted correctly, you'll have to use a multiply factor of 0.0036. For imperial units, the airflow is expressed in cubic feet per minute, or CFM, the velocity in feet per minute, and the duct diameter in inch. For the unit conversion, you'll have to use a multiply factor of 0.0069. Let's do a simple example. You want to calculate the airflow in a 200 mm duct in which you measured an air velocity of 20 meter per second. The airflow in that duct is 2260 cubic meter per hour. For the imperial units, the diameter of the duct is 8 inches and the measured air velocity is 4000 feet per minute. The airflow in that duct is 1390 CFM.